So we've already talked before about average rate of change. It was one of our vocabs. It is a formula that you will need to know for at least the rest of this semester for sure. F of B minus F of A over B minus A is just the average rate of change over some interval from A to B. So remember, look what they've done. They've taken some x value of A on a curve, some x value of B on the curve. They have connected it with what is called a secant line. And then whatever the slope of the line is that connects it is the average rate of change over that interval. So maybe highlight that formula for yourself. That formula isn't going anywhere. It is something you need to know. Now, in calculus, that formula is used, but a variation of it is actually a little more helpful algebraically. So in this lesson, we are going to practice using the alternate formula, which we're going to see in a second. But first, let's look at problem number 1. Actually, we're not going to do number 1. We just don't have enough time, and I want to give you some time to work on this. So we're jumping instead to problem number 3. So I just want to practice finding the average rate of change for a given function, because I know that is something you're going to have to do. So let's write down our formula. Remember, in function notation, it's just f of b minus f of a over b minus a. If you were using point notation, remember it's the difference of the y's over the difference of the x's. So it's the change in y's over the change in x's, okay? Don't get that switched. It's very easy to do that. So it says we have two functions, f and g. We want to find the average rate of change of f over the interval from 1 to 6, and then again over the interval from 3 to 10. Okay, so first let's do the first one. So we're going to go from 1 to 6, okay? So what we're going to do is we're going to call this A, and this is B. Beginning and ending, x's should go from left to right. It should always be that, okay? So we need to find f of 6. We need to find f of 1. Now, we're using the f function, so we're using that square root of x plus 3. So this would be the square root of 9, or 3. This would be the square root of 4, or 2. So if we set it up, we're going to get f of 6 minus f of 1 over 6 minus 1. Do you see how these are your ending position? These are your starting position. It should always be that way. So we already calculated f of 6 was 3. We calculated f of 1 was 2. 6 minus 1 is 5, so we might as well do that. 3 minus 2 is 1, so the answer is 1/5. Now that is the average rate of change from 1 to 6. So we can see that it is going up 1 and over 5 if we were to connect those points. Now let's do it again. They wanted us to do it from 3 to 10. So if we are doing it from 3 to 10, we need to find f of 10. That is going to be the square root of 13. We need to find f of 3, which is the square root of 6. Neither of those square roots can be simplified. So in this case, it would just be our f of 10 minus our f of 3 over 10 minus 3, or 7. Now, if you were to enter that into iMath, please make sure you use the fraction button or surround this entire thing by parentheses before you hit the division bar. That will also work, and then you won't have to necessarily use the little fraction, that yellow box, but fraction bar, that's helpful. Do we have any questions about 3A? Okay, now let's look at B for a moment. Now B says to find the average rate of change of G over the interval from 1 to 4. So you'll notice this time they are saying that we have to use the G function. So I'm just going to write the G function right here. So we've got it. So the first time we're going from 1 to 4. So from 1 to 4. So we have to find the ending position and the beginning position. F of 4 is just 10 divided by 4. Let's go ahead and make that, I think a decimal would be okay. It's a nice decimal, I believe. Yeah, that's 2.5. If we put in 1, 10 divided by 1 is 10. So what is our average rate of change? So that function, if we were to draw it, I believe it's a hyperbola, I think. I think there's like 2 pieces. Anyway, you could find that point and then those 2 points and then connect them, okay? But remember, it's going to be f of 4, ending position, minus f of 1, starting position, over 4 minus 1. This tells you the order that's going on the bottom, okay? So we know those. That's 2.5 minus 10 over 3. That's negative 7.5 over 3. Now, 7.5 is divisible by 3 rather nicely, and it gives us negative 2.5. So that means it's going downward from an x value of 1 to an x value of 4. That's what that negative indicates. If we were to connect the points, that is the slope of the line that connects those 2 particular points. But if we change the points, then we're going to get a different slope. We're going to be on 2 different locations on the graph. So this time we're going to do it again from 5 to 10. Okay. So if we calculate f of 10, our ending position, that's 1. 10 divided by 10 is 1. If we plug in 5, our beginning position, 10 divided by 5 is 2. So our slope is going to be our ending y value, 1, minus our beginning y value, 2, over our ending x and minus our beginning x, okay? So these 2 should go together, and how can you check? Look at this right here. I plugged in 10, I got 1. I plugged in 10, I got 1. This one, I plugged in 5, I got 2. So they should always be a pair above one another, okay? If you switch them up, ending and beginning, the only thing that will happen is it might throw a negative down in the denominator, and then you'll have to fix that. So by going from left to right, it will provide you with a positive value down in your denominator, which makes things just like work out nicer when it's all said and done. And then on top, we're going to get negative 1 over 5. So that would be the slope of the line between 1 and 2. So it's not as steep of a decline as it was from 1 to 4. From 1 to 4, it was a negative 2.5 decline. Now from 5 to 10, it's not quite as steep at that particular part of the graph. So if you were to take a calculus class, this becomes super important. It is something related to the slope of a secant, which eventually in a calculus class gets us to something called the slope of a tangent. So these are formulas that actually I was talking about yesterday in my calculus class. So it is something that occurs later on. And so it's very important that you understand the average rate of change. So then that's going to lead us to the next thing we're going to talk about, which is called the difference quotient. Now, before we do that, do we have any questions about this example? Okay. Now, if we could, now let's look at the difference quotient. Could you please highlight this formula right here? Now, that is a formula you're going to have to know by heart. We're going to need to know how to do it. It is super important that you know the difference quotient. Now, here's what's super important about the difference quotient. In a calculus class, they do something called a limit. And a limit, you sometimes have to manipulate the algebra of things that are happening. And what's great about this formula is we should be able to, when it's all said and done, divide off the h that's in the bottom, okay? It is technically, if you look, a version of our average rate of change. But what they do is they look at where that h is getting smaller and smaller and smaller, okay? That difference between x and h gets littler and littler, and then you end up with that formula on the right that I've circled being very useful. Okay, so that being said, I want to practice using the difference quotient. On Friday, you're going to have a 5-minute quiz where you're going to have to do like 2 of them, where you're going to do 2 difference quotients. I'm going to give you 2 functions. I'm going to say find the difference quotient for those functions, okay? So let's start out with some linear ones. I'm going to do 1 and 3, okay? I might not do all of these, and that's okay, okay? I want to start out with number 1. So over here on the side, I'm going to put f of x plus h minus f of x over h to remind you what the difference quotient is, okay? So underneath it, here's what I tell my calculus students when we're going to simplify the difference quotient. Here's the strategy I tell them. Find out what is f of x plus h and what is f of x. We're just finding what these particular values are independently of the difference quotient. What are those things? If I said, hey, find f of x plus h and find f of x, what would you do? Okay. Okay, f of x plus h becomes the input. Wherever the c is sitting, I'm going to take it out. I'm going to put in x plus h. So that's negative 2 times x plus h plus 10. Now let's simplify that down as much as we possibly can. And so that's negative 2x minus 2h plus 10. Now the second one's even easier. We are going to replace the c with an x. So that's just negative 2x plus 10. Okay. Now that we have them, we're really halfway there, okay? So this is x plus h. It's going to go right there. This is f of x. It's going to go right there. But you see what's in front of the f of x? A negative sign? So that means we need the opposite of f of x, or we need to subtract f of x, however you want to think about it. Okay, so let's plop those into the difference quotient. Okay, so we're going to write out f of x plus h, which is negative 2x minus 2h plus 10. Then we're going to have a minus symbol. Then in parentheses, I'm going to put f of x, negative 2x plus 10. So that's that, all over h. Okay, so let's break it down one more time. This is x plus h, f of x plus h. This is f of x. It always goes in parentheses with the minus in front, all over h. Okay. And now it's just algebraic simplification. We are going to simplify it as much as we possibly can, and if we did it right, the h will always cancel. If your h doesn't cancel, it's wrong, because it will always cancel, okay? So what do I mean by that? Let's look at the top. We get negative 2x minus 2h plus 10 plus 2x minus 10 all over h, because I distributed that negative. Okay, now watch what cancels. Let's cancel some things out. The negative 2x and the positive 2x, gone. Positive 10, negative 10, gone. The only thing that remains should remain and contain an h. That's the way to check your algebra. The thing that remains should contain an h. So we get negative 2h, which is divisible by h, divided off our answer is negative 2. Yay, that's the difference question. The h will always cancel. If it doesn't, you did something wrong in your algebra, okay? Okay. Any questions about the first one? Now, we're going to do it one more time. We're going to do it with number 3 with a linear function. We do want to do a quadratic, but I want to do a linear function next. Okay, so let's write down our difference question. Sorry, my notability just died. Probably everything I just did died too, but oh, no, that didn't. That's good. Okay, so let's go to number 3. We are going to write over here to the side, f of x plus h minus f of x over h. That's our formula. We're going to plug in x plus h. We're going to plug in x so we can plop it into the formula. If we plug in x plus h, we get 9 times that. So it's 9x plus 9h minus 2. Do you see this time I didn't show it in parentheses, but I remembered to distribute the 9. So you can do some things along the way to kind of simplify things. And then f of x is 9x minus 2. Now let's go ahead and let's plug our x plus h right here. Let's plug our f of x right there, okay? When we do that, we get 9x plus 9h minus 2 minus off our function f of x all over h. Let me say that again. This is our f of x plus h minus our f of x in parentheses all over h. And now we just do algebra when we simplify it as much as we can. We should get to the point where we are able to divide off the h. So if it does not contain an h at this point, it should cancel. It should have an opposite sitting there, and it does. Positive 9x and negative 9x. Yay, that's good. Yep, positive 2 and negative 2, thank you. So we're left with 9h over h, or 9. So the linear ones are really nice. They're usually going to simplify all the way down to a number. So that's great, okay? But I want to do one that is a quadratic. So we need to do 5. 5 becomes a little more difficult just because of the nature of the algebra. But let's write down our difference question to the side here. F of x plus h minus f of x all over h. Now at the end, if it's not divisible by h, I did something wrong. Okay, so what is f of x plus h? Well, that's going to be 8 times the quantity of x plus h squared plus 7 times the quantity of x plus h. There's a lot of algebra there that I got to fix. Now, over to the side here, let's do x plus h squared, because that throws my students a lot, okay? It's always going to be this, so if you know what the pattern is after this, you can just always write it down. Okay, x plus h squared is x plus h times x plus h. If we were to FOIL it, you always get the first term squared plus 2 times their product plus the last term squared. It's always that, no matter what. So if you know that binomial expansion, that x plus h squared is always that, the first term squared plus 2 times their product plus the last term squared, do it. So let's replace that into our formula here. So that's 8 times x squared plus 2xh plus h squared. And then the 7 will distribute that. So now let's distribute those things in. So we're going to distribute the 8. We're going to distribute the 7. We're going to get 8x squared plus 16xh plus 8h squared plus 7x plus 7h. It is very easy to make a little algebraic mistake at that spot. So be careful. Follow order of operations. And please know this. Learn that x plus h squared is always x squared plus 2xh plus h squared. Always, always, always. Okay. Okay. We haven't done f of x plus h, or I'm sorry, just f of x. So now you just replace f of x. So the b's come out and the x's go in. So it's just 8x squared plus 7x. It's just our input has changed from b's to x's. So now we have the things to plug in. This is going to go right here. This is going to go right there in parentheses because we have to subtract it. Okay. So now when you list it, be very careful. So we're going to get 8x squared plus 16xh plus 8h squared plus 7x plus 7h. And we're going to minus off the purple one, 8x squared plus 7x, all over h. Now it's easy in the transfer to mess something up. So just always compare, is that what I had? Oh yeah, that looks good, okay. Now let's distribute the negative into our quantity. I'm gonna just kind of scooch this in just a little bit. I write too big. Okay, now we get 8x squared plus 16xh plus 8h squared plus 7x plus 7h minus 8x squared minus 7x all over h. All I did was distribute. Now you can do that ahead of time. You don't have to put the parentheses there, but I found that the parentheses always help my students to remember to distribute it to all the pieces. Otherwise, they sometimes just put the negative on the 8x squared and they don't put it on everything. Okay. Now let's start canceling some things out. There's a positive 8x squared and there's a negative. If it doesn't have an h, look down your list. It should have an opposite. You have a 7x and a negative 7x. Do all the pieces that are left contain an h? That's a good indication that we did it right. Look, that one has an h, that one has an h, that one has an h. Great. So now, list them out. Divide by h. So all of the h's go down by a power of 1. So our final answer should cancel out the bottom h, or you did it wrong. It is 16x plus 8h plus 7. That's our answer. Quadratics are harder. There's more to the process. But it's just algebra, and you have to just be careful. I don't know how else to tell you, okay? Do we have any questions about finding the difference quotient for a quadratic? I always like them because I know that h is going to cancel. So if I make a mistake, I can find it. Maybe you put a sign wrong somewhere. Maybe you forgot to distribute something. Just be careful. But everything that doesn't contain an h will cancel. So the algebra of it, it feels nice because we kind of expect if it's right or wrong. Everybody good with that one? Okay. So that's your investigation. Go ahead and turn it in, and then open up the pre-class M37, today's assignment. Go into iMath at this time and open up pre-class M37. Okay. Now, there's usually some boxes that will tell you some things that you have known from the past. So look here, it's just your slope formula that they have mentioned at the top of the page. Now let's jump to where it says if the function h represents Ben's distance. Okay, so let's go to the first problem. It looks like this. It says, now again, remember, you and I might have slightly different problems, okay? So just please adjust your numbers accordingly. But I want to show you how to enter your answers so that we can walk through this. So then when you get to the real homework, you will be more comfortable, okay? It says, if the function h represents bend distance from the starting line in yards in terms of the number of seconds t since the race began, then Ben's average rate of change over this 5-second time interval from 4 to 9 seconds is the constant rate of change m that we see here. So we know that formula, that's our average rate of change formula, okay? It says if Ben ran 27 yards over a 4.5-second period while varying his speed, his average speed over that 4.5 seconds intervals was, okay? All you need to put in there, at least this is what I put on mine. Your numbers might be different, but I just did 27 divided by 4.5. I let iMath do the math for me because it's the change in yards over the change in yards over the change in seconds. So it would be yards per second would be what you want, okay? It would be yards per second, okay? So this would be yards per second. Now, if you want to actually, if you have a calculator and you want to divide that out, go for it. But I just let iMath do that for me, okay? Everybody good with A? And iMath is doing their thing. Okay. Now, let's talk about what does that tell us? Well, it tells us two things. It is the average rate of change of the function on an interval is the constant rate of change that produces the same net change in the function's dependent variable on that interval. All that means is the average rate of change is the slope of that secant line. That's a fancy way of saying that. And then mine is this one right here, is Ben's average speed over the 4.5 second interval, okay? It's not this one because we don't know if he ran it most of the time because maybe he had a burst that he went really super fast that made up for the fact that most of the time he was slower. So who knows? We don't have an actual function given to us, okay? Everybody okay with this first little section? It's all entered, you're good, okay. So now let's jump down to something that uses a little more of our thinking about functions, okay? So let's take a look at this one. It says, consider the function, again, my function and your function might be a little different, x squared plus 4x plus 2. It represents the plane's altitude in thousands of feet above sea level in terms of the number of minutes since lifting off the ground. So it says, what is the plane's altitude 1 minute after lifting off the ground? So you're just going to plug in 1 into your function. My function, your function might be different. If I plug 1 into my function, I get an answer of 7,000 feet. Now, yours and mine might be different numbers. Maybe you get 8, maybe you get 9, I don't know. What is the plane's altitude 4 minutes after lifting off? So now you're going to have to plug in 4 into your function. I've seen one here that says 5 minutes after. So whatever that number is, please plug that into your function at this time. I'm going to plug 4 into my function. And my answer would be 34. Okay. Now, the reason those two numbers are really important, please make sure that you submit those and make sure those are correct, because that's going to help us answer C. What is the plane's altitude? What is the change in the plane's altitude as the time since the plane lifted off increased from 1 to 4? So it's just whatever you get at 4 minus whatever you get at 1. My particular numbers were 34 and 7. So you're just going to subtract what you got in A and B. It's B's value, the ending, minus A's value, the beginning. So I don't know what yours is, but 34 minus 7 for me is 27. And it's a positive because it has increased, at least for me, it is increased, okay? Everybody good with those particular ones? Okay, now see D where it says use function notation to represent the change you computed in C? They want you to enter this right here. Now, I don't know what yours were, but I would enter f of 4 minus f of 1. Ending minus beginning. You might enter f of 5 minus f of 1, f of 6 minus f of 2, whatever your numbers happen to be. That's all you're entering. You're not entering anything more than that. Okay. Everybody good with that? Now, let's look at E. It says use function notation to represent the average rate of change. That's that change in Y over change in X formula. So be careful how you tell iMath how you enter this. You could, without using the little fraction button, go parenthesis, f of 4 minus f of 1, parenthesis, divided by, parenthesis, 4 minus 1. So you can do it like that. iMath is perfectly okay with that sort of thinking. Now, your numbers might be 5 and 1. Your numbers might be 6 and 1. My numbers are 4 and 1. So it's f of 4 minus f of 1 over 4 minus 1. So check your work there. You might have to use a lot of parentheses. Surround your top by parentheses, your bottom by parentheses. Everybody get that one to work. Okay. Now, for F, you're going to actually do that calculation, but you've already got the numbers. It's what I got in C divided by the change 4 minus 1. So it's my answer to C divided by 3 for me. So it's this answer here, the change in the altitude over the change in the time. The change in the altitude for me was 27. The change in the time for me is 3. So 27 divided by 3, I got an answer of 9. And that is thousands of feet per minute. Because the change is 1,000 over the minutes, which is minutes. Yes. It's just see whatever you entered here. It's just the calculation of the difference in your minutes. So if your minutes were 4 and 1, do 4 minus 1. If yours is 5 and 1, do 5 minus 1. So like I've seen it where it's 5 and 1, so you have to divide by 4. I had to divide by 3. And what does that tell us? Well, that is the constant rate of change. If they were going perfectly the same thing every time from 1 minute to 4 minutes. It's not the actual rate of change, because the actual rate of change, they might have been going, they're at a different rate each particular second, each particular minute, okay? So everybody done then with that problem. Okay. So then they are mentioning that average rate of change formula. So feel free. Well, you can't do anything about it. But anyway, now let's jump to the last thing, and then we'll be done with our pre-class M37. It says represent the change in the dependent quantity using function notation. Okay, so remember our dependent quantity is our Y values. So let's highlight the Y values. I'm going to highlight, you can, but okay. So let's just look at how our dependent quantity, our Y value changed. It's just f of x plus h minus f of x. That's how it changed. I don't know what those numbers are. They didn't ask me that, okay? Now, 2, we have some thinking to think about. It's really now the change in the independent quantity. So it's x plus h minus x. What is that simplified down to? What is that simplified down to? That simplifies down to h. So that's what they want you to enter there. And then that leads us to a new formula for the average rate of change, which we have discovered earlier, the difference quotient, which is just, again, you'll have to do in parentheses, f of x plus h minus f of x all over h. So that is M37. Hopefully everything has submitted for you. We actually have a little bit of time in class. How wonderful is that? Please, at this time, yesterday we started 3-3. There's homework 3-3. Take some time and look at homework 3-3. We just did some of 3-7. So now's a good time to start looking at homework 3-7. Don't look at 3-4, 3-5, 3-6. Don't look at those yet. We haven't done anything with them yet. I mean, you're welcome to, of course, but focus on 3-3 and 3-7 at this time. And there you go.